A very warm welcome to OXXPUN, the technical magazine with Wolfgang Rudolph. Hello and a very warm welcome. I would like to tell you something today from photometry. Photo, we all know, I don't mean a picture but photon light and all that, and everything what has to do with light. And metric measuring, we have to, in many areas of our technical life, maybe have to work with light. And that what you don't see, what happens beforehand here in the studio, all the lamps have to be switched on and the direction has to be right, the brightness has to be correct, that all has to be comparable, it hasn't to be lighter to the right as to the left, or such things. So I've brought here a toy from me. It isn't a professional device that we use here in the studio, but you can see it shows something. Here at the top there is a match eye, and when I cover it, then it goes to 0 lux, then it starts what are lux again. When I open it again, it goes back to 820 lux. Normally it is measured when the chief lighter comes over to me and holds it in front of my face. And then he looks if everything has the same brightness. He has a lot of experience, but measuring is better than thumbs up. That's the same in all other areas. Lux, we had this expression, what is it exactly? Previously, it was said to our illuminates, some people say bulb to it, they have a certain performance. This, for example, has 42 watt. Don't complain, it has really 42 watt. It is written on it. That's what it looks like. That means though the power consumption of the net watt on electricity flows in. That are 42 watt, not on electricity, that would be amps, but from that the resulting power. But what comes out of here? Is it less? This piece has a working performance of maybe 3 to 4%. That is why the EU had these things forbidden and abolished. And they changed to LED because the efficiency is larger. To compare, around 30% comes out, in the meantime a bit more, but by worse ones a bit less, but approximately. Like I said, around thumbs up. So now we have the light current, not the current that goes in, but the current that goes out. And that is with lumen designed, LM. You can find this on many illuminates which substitute these. And I can see on them this has 500, this has 800, this has 1000. What do I do with this? That is the whole amount of light, current, what comes out of here. That disperses, will try to be linear, spherical. Of course it isn't not so. But if it was, it would expand evenly. That is the lumen. But we want it on a certain place. And I can show you here with my torch, when I put my light circle here, let's make it a bit darker, so that is the total amount that comes out. Not whole directed like the illuminates. And now the light is exactly the same. But on this space, there you can see my fingers totally lit up and the whole light is exactly the same. But on this small spot, there it is totally lighter, and when I put the light in onto a larger spot, the light is not as bright. You can see on my finger, that means that is why we have the unit lux. Lux means the brightness on a certain space. And when I go from an illuminate out a large space light up, then it is clear on a large space. Falls a small lighting unit onto the space as if I light up a smaller space, and that is why we say at our workspace we have to have so much lux by an operation in a clinic. We have to so many thousand lux. On a toilet we only need 50 lux. We know where everything is. So it is calculated in the office you should have around 1,000 lux, and that you measure with such a device, like I have here. So and now the question is, how is it measured? And that is basically simple. I have here what you call an old power bank. I took it apart where the battery was broken, and I have stuck a cable onto it. That is what is called a photovoltaic solar cell. It collects warmth as well, but turns warmth into light. But the whole thing with this is that it should turn warmth into light. We have connected a milliamp meter to it, and as you can see with the studio lighting, it shows something, and when I go over it with my hand it goes away. That means we have the possibility with a solar cell built on roofs or even on cow fields, the possibility to produce from light electricity. And that is naturally proportion to what light comes into what electricity comes out. So I have the possibility to look quantitatively when the sun burns from the sky, how much electricity really is produced. How can I use that for me? Earlier we had in our photo camera, as it was with chemicals, a little cell in it which showed a scale a bit calibrated, showed a scale which was calibrated. Today we have other things, something like this here. That is a phototransistor, and there are also photodiodes. That's what it looks like. You can maybe look a bit inside the chip. And this does exactly the same as the solar cell does, but specialized onto a certain wave band, and also specialized to receive certain light amounts, which I can later strengthen and measure. The test of it is not to get energy out of the sunlight or any other light source, but the signal from the light to implement into our electric current area, so we can measure it and display either with an ammeter or naturally with a measuring amplifier or digital, and that is then calibrated. And when it is calibrated, I can tell you exactly this amount of light here, so many lux I have here, on this or this or this or here in front of my face, so much to light. Now we want to think, what can I do with this light when I can determine the quantity of the light on a certain spot? Then I can look here how transparent is here my fluid. I have brought here, so to say, a battery. We'll take a small lamp and have a look. When I hear shine, there comes so good as nothing through. It is pretty dark here, it is light blue, there is little redness. So I'll go a bit away, and so green. And now the question is, and that is white, totally transparent. So, and now we are back to estimating, okay, that is darker, that is lighter, not very accurate. But when I now use a measuring instrument, which lights inside of the fluid, and for one, the reflection normally done at an angle of 90 degrees, I light into it, and then at an angle of 90 degrees I measure it with a photodiode and a light what goes inside at a certain wavelength, also with the LED, a light imitating diode sent in, or also with 3 different wavelengths, 3 lighting diodes and accordingly 3 receiving diodes. I can determine the cloudiness. How cloudy is it? You can simply say that here is totally cloudy, that nothing passes through, and that here, well, how cloudy it is we can't say with our eyes. And for this we need again our measuring instrument. So light you can determine with a lux meter on a certain spot how light is. Illumine we can't determine straight away, we have to trust the manufacturer. He has to measure it in a certain measuring cell. You can imagine if you have a multi-purpose hall and hang one illuminator up. It is a bit different as when you hang it in the guest toilet. What we just talked about. In the guest toilet is relative lighter with the same light current as in a large hall. It is lighter with the same light current, because on a large surface the same amount of light source as of the small surface. So, I think I've done enough to try and explain the related themes. So now we have to think about what we can do with this. We can, for example, components of fluids investigate and determine when we, with different wavelengths, shine into, and see what is absorbed and reflected. And if we calculate the complicated, but that is what the measuring devices do, then we can say, okay, that is what it looks like. We can put a certain chemical into this fluid, and then determine what ingredients are in this fluid, because the chemicals we have put in we know, and they react with the ingredients and change then the cloudiness. And this cloudiness is a bit difficult. It is measured in NTU. And I don't want to say, it would probably say it wrong anyway, this NTU unit held in guidelines, and they are identical to the FTU units, they are just different values. This is necessary for people who are trusted with these themes, who have to assess and qualify. So we can measure light, we can measure cloudiness, we can measure ingredients, everything with light, with that what the sun gives us. No, not with what the sun gives us, we need special light. And what types of devices there are, I have had a look at. When it is about cloudiness, we all know what that is, when something is cloudy. That could be a feeling, but we can't measure that. But everything what is in the chemicals and industry is fluids, for example. There you can naturally measure. I have here a measuring device from PCE, the TUM20. That is a TUM20, so you can see it better. I'll turn it on. You can see the cloudiness of fluids precisely measured, but first you have to adjust it. Basically calibrate it. Here at the top is an opening, and delivered with it there are two fluids. For one, this one here, it has 0%. That means not cloudiness, not NTU. And this one, I think you can see it has 100 NTU. And I'll stick them inside. They must be put in with the marking to the front. I won't do that though, I've just done it. You shut it, and then the calibration is started. And because of the fluid, it sets itself to 0. NTU 1, and when that has finished, we take the NTU 100, put this also right away around into it. Yeah, we do the same, and then we have a 2-point calibration of 0 and up to 100 NTU. The measuring area goes much further. It goes up to 1000 NTU. And when we have done that, the device is, so to say, calibrated. Then I have here from my stock what I have built up here. I have a 10 milliliter delivered with it, a probe put in and shut it. It is shut. No, it doesn't want to. And then I can test it. So now it is tested, and a built-in timer says how long, with an infrared light diode, and the probe is lightened up, and what comes out on the other side, and then it shows me how much NTU I have. 0.42, that is my test fluid. So the whole thing is very simple. You can, but you don't need to do the calibration by the next measurement. You can simply do it in certain times. When the device was turned off for a long time, it is sensible. Important is also that the bottles are clean. There is a cleaning fluid delivered with it, and a cloth with which you can clean it all, that no dirt is inside. Infrared you use so that you can measure colors, fluids. Because the color, this is red, doesn't matter. Because in infrared area are colors irrelevant, and only the cloudiness is measured. An exact procedure, and that this device, the EN27027, fulfills, is normal, the usual norms. Then we are able to achieve a scientific technical result. When you want the quality of a fluid, for example, water, what components it has, what is in the water, then with our technique today it isn't so simple. You need high complex devices, and this device, what I have found, the CP30 from PCE, it combines a super simple usage when you just follow the guide in the manual. It is step for step explained. Then everyone, also not professional users, to this I count myself, to simply operate and get good results. Firstly, what does this thing do exactly? This little device here, it is able, the pH value, free chlorine, total chlorine, cyan acid, alkalites, active oxygen, chloride dioxide, brome and hydrogen peroxide, in low and high range area divided, total hardness, calcium hardness, urea and pH in B, the antibiotics, what is in the medicine area, determine in the fluid. Everything I've just said you can do with this. How do you do this now? The device does it. The device had 3 built-in LEDs with different frequencies, or wavelengths you say more to. 530 nanometer, 570 nanometer and 620 nanometer. With this it shines into the probe and measures then in the single wavelength areas what shines through. Okay, you could say, alright, that is simple, but no, not exactly. You have to naturally, before what you want to test, you have to prepare it chemically to get the corresponding values. You use the delivered, what I call tablets, chemicals in small tablet form. You can see them here. Processing. I just want to show you how it is done. I take off the safety cover. I have here one of the cuvettes which are delivered with it. 2 of them are there. They have to be clean naturally, no rest in them. They come into here. And then I put 10 milliliter of the probe into it, which I want to measure. Oh, I made a mess, Rudolph. That was clear water, so nothing will happen. Now I put a tablet in. Now I have to grind the tablet with the delivered grinder. It takes a while, around 2 or 3 minutes. That is why I won't finish totally here. Then the light protection cap is put on and I can start my measuring process. Because I have different ingredients to determine, different chemicals here. If you look here, there says alu, alkali, there it says DPD, phenol, and so forth. It reacts naturally differently with my probe. And depending on what the contents of the probes are, you can then, depend on the cloudiness in this special case, determine the wavelength, how high the concentration is, and what I want to measure. So the measurement is finished. I can't show you it without it spilling out. I'll just open it, take this out, I'll tip it into here. It won't explode straight away. So, and then we can see here on the display, oh, it is pretty small. Now it shows naught again. Then I have different menu points which I can choose. It is pretty hard to get it into the camera, so now you can see it. I also have the possibility to choose the language, the unit with which the measured results should be shown, millipole, proliter, and so on, and all these things. And I have the possibility to turn on Bluetooth, because this device sends what it has saved with Bluetooth to a computer. There is a Windows software offered, what you can download for free, and an application for Android, and then I can transfer the data to a tablet or mobile and look at them. So I've opened this, and that is what the software looks like. I have different types of evaluations. I have my measured results. I can show them graphically and work on them and evaluate them. So a device with which you can at home, your own chemical laboratory have or could have, if you wanted to. But who wants that? We leave that to the professionals, because that is a professional device with a simple handling and, how do I say, a natural way to analyze a probe with unidentified ingredients. Discover and order the newest measuring and testing equipment now at www.pce-instruments.com.